Okay, and so this is a summary of just everything I didn't get the first time. Okay, and so to start off, Carl Lashley did the surgical separation of motor regions and found out that that did not affect maze learning. The only way you can affect maze learning is through destroying cortex, and that's called graceful degradation or mass action. And basically what that is it's just saying that brain or memory is like spread across the whole brain. It's not in one spot. Okay, and then Hebbian did LTP, and this was proved by Lommel and Bliss through a rabbit hippocampus. And there's two aspects to this: specificity and associativity. And you can think of it as like don't think of specificity as like a positive thing. Think of association as a positive thing because it's good to like associate with people. And so that just means that neurons that fire together wire together. And then specificity is just kind of like being exclusive, and the ones that don't fire aren't going to get to wire together. Okay, and just to remember, the in vivo model of LTP is the glutamate NMDA receptor. And the 4 LTP changes are size, cleft, splitting, and forming new spines altogether. Okay, and kind of clarifying what the MTL does. The MTL parts are the two biggest parts are the hippocampus and the parahippocampus gyrus, and then that branches down into parahippocampal cortex and anterorhinal cortex, and then that goes into perineal cortex and entorhinal cortex. Okay, and so then like the real pathway for MTL activation that you need to know is actually it goes from the associative cortexes to the perirhinal plus parahippocampal regions. Okay, so it starts at the associative cortexes, and then you meet perirhinal and parahippo. So perirhinal and parahippo. So it's kind of like the two off-color ones. So you meet the perirhinal and parahippo first, and then you meet the friend, your rhino friend. So entorhinal cortex, you take that to the hippocampus. And so you meet the two oddballs first, perirhinal and parahippocampus. And then you go through the entorhinal to the hippocampus. And then once you're at the hippo, that's where you want to be. And then he takes you with his million friends. So you go through the fornix and mammillary body to the anterior thalamus and then to the cortex. Okay, so just the main thing to know is that it goes from associated cortex regions straight to perineal and parahippocampal. So perirhinal and parahippo. Okay, and also MTL amnesiac was HM, and just to remember again, HM had a bilateral temporal lobectomy, and that means that he made new declarative memories badly. So like he couldn't. Yeah, so like he didn't know what was happening in his life, basically. But he could get new skills, i.e. the mirror drawing, and he did have implicit knowledge of things. And also MTL is important for encoding of declarative memories, and we kind of know that because declarative is episodic. And using this, you can kind of go on the test and work backwards for if it's asking about like semantic or episodic, then you are going to know that that's declarative. Okay, and also just know that the MTL is not needed at all for working memory. I think before I thought that the MTL was using, or the working memory was using MTL for like a little bit, and then like if it was good enough, it goes into the cortex, but that's not true at all. What it's actually doing is working memory is its own thing, and it doesn't need the MTL. Like you can have working memory. I mean, that's shown by HM. Like he kind of had working memory, and he didn't have an MTL. Okay, and so just know, yeah, you don't need it for working memory. Okay, so independence of working memory from long-term memory. We know this because of the recency effect and distract and forget, and also if you present things slowly, it's going to result in better long-term memory. Okay, and then getting into the fast-paced one, Warrington and Chalice were the ones that did KC, and KC had a left temporoparietal cortex lesion, and so I just really need you to remember that. KC had a left tempoparietal cortical, so that's LTPC. So KC, LTPC. KC, LTPC. KC, LTPC. KC, LTPC. Okay. You can think of KC as LTPC. Think of your childhood friend Kathleen, who could be KC, and then what does LTP, comma, cunt make you think of? Okay. So LTPC, and that's related to Kathleen. Okay. And so HM can encode new non-declarative memories. And so non-declarative memories would be like priming and stuff and skills. But he can't do declarative. Again, just review. MS cannot be conditioned. Okay, so MS, and that's because MS was missing. What was MS missing? MS was missing, oh, the opto thing. Okay, and MS cannot be conditioned. So just know that MS can't be conditioned. Okay, and the frontal and parietal lobes for both working memory and long-term memory. Okay, so that's for both of them, working memory and long-term memory. Great. And then consolidation of these declarative memories goes from the MTL to neocortex, and in sleep, you replay stuff for the mice maze, and the two things that you're replaying are the entorhinal grid cells and also the hippocampal trace cells. Okay. Okay, and then there's different models. So the multi-trace model is basically saying that like episodic wants to stay in the hippocampus and semantic doesn't want to leave. Okay. Yeah.